welcome back to my code review series, a series in which you guys send me your code and projects and I just roast them apparently. Today, I'm actually not in a roasty mood today. I'm actually feeling a little bit kind today, which is, if you know me, it's a bit rare, so take it. And I came across this beautiful email in my inbox, Radar Contact by Bogdan. Hello, I've created a 2D air traffic controller game using SFML.
My computer is struggling. Holy shit. Okay. I think it's better. Hopefully.
As a project for university.
You don't have to make the next Unity for it to be called a game engine. Something simple also counts. So I will talk about why it isn't hard to make a game engine, but also why you would want to do it in the first place, and also how I would recommend doing it. Think for a second what the best tip I could give you about making a game engine could be. Trust me, I have something even better that probably didn't even cross your mind, so stick till the end for that. A few years into my programming journey, there was this game called Pixel Dungeon that I used to play a lot and I'm still playing from time to time. And being confident in my programming skills, I thought I could implement something like that myself. All I needed to do basically was put some pixels on the screen. Then I could draw the level and the characters using a fixed grid, and that was the game basically. I was really hyped for this project, but there was a big problem. I wasn't able to get any graphics library to work, so I couldn't draw anything on the screen. But then someone showed me Unity for the first time, and it was really cool. It could do a ton of stuff for you, but at the same time, all I wanted to do was place a pixel on the screen, because I knew how to work my way up from there to make a game. So I didn't really want to mess with other new things. But of course, Unity doesn't work like that. So I had to learn how to use it. And I made a simple prototype, but I wasn't satisfied. I was spending around most of my time in Unity Editor, messing around with stuff or with other programs to paint maps and generate collision walls for them, and then I was wasn't able to make the player the exact same size as the map tile size, and the project didn't feel satisfying at all. So I gave up on Unity and continued my quest in trying to get graphics to work. And I eventually did it, and made this Terraria game with it. But this graphics obsession continued because I saw this Hobson video of a Minecraft clone in C++. This Terraria clone was just the beginning before moving properly to 3D. And I eventually learned OpenGL and made one Minecraft clone, and another one, and another one. And also, eventually, my own game engine. So then I hear you ask, why make your own game engine? Well, here is the thing, there are three kinds of people in this world. People that just want to make games, people that want to code and happen to find game dev related topics very interesting, and would also optionally like to make a game, and people that aren't in either of those categories, like web devs or normal people that don't like coding. But we aren't friends with those. And this debate of reinventing the wheel and making a game engine from scratch is stupid. If you just want to make a game and don't care about programming, then it doesn't make sense for you to make a game engine. Why would it? Maybe if you just want to make a very simple game and you already know a ton of programming, then there can be some advantages of making the game from scratch. This game was made from scratch, and I don't really think a game engine would have been of much help. I mean, the entire rendering pipeline is written from scratch to look like this. But if you watch my videos, you probably are into the second category, where you just like low-level programming. If so, you should probably subscribe. I mean, look at the name of my channel and the type of videos I make. But look, I know people will tell you that, oh, we will never make a game like this, or we will never make a good game, and you are wasting time. And let me tell you a secret, but promise you don't tell anyone. All these game engines were made by people and are still being updated by people. I see a lot of people use Godot right now, and they say it's way better than Unity or Unreal. Guess what? What if 10 years ago, the Godot creators thought, yeah, why reinvent the wheel when I have Unity or Unreal? You wouldn't have Godot today, would you? So why if you just want to make a game fast, making a game engine isn't an option? Some people people just like coding interesting things from scratch. And trust me, you'll learn a ton of things by making your game engine. And I promise, you'll love just working on this project just because it's interesting. And next time you go to a game jam, you can make that game in your game engine. And when you will work in a game dev company, you'll work on the game engine team instead of the gameplay team. And I'm pretty sure they do more interesting things there. And you're also paid better, so that's a win for me. Looking back on all of those haters, half of them probably never released a game anyway. But I actually have. This game was made from scratch, and this game that I'm currently working on is made in my framework. But what is a framework, and how does it differ from a game engine? Well, people usually think of game engines as programs where you have an editor and tools and entities and scripting, while a framework is more like a bigger library that gives you all the things you need to open a window and draw to it, maybe with the main function already written for you. So, should you make your own game engine or framework? Well, a game engine has a very big disadvantage that people don't talk about, and that is that it's trying to suit every possible game type. And I think it's obvious that one-fits-all solution isn't the best for anything. It is just good for most things, and not so good for others. I would rather spend some more time making special systems for my game, because that will save me time in the long run. Game engines usually use entity component systems and stuff like that, but I never use that in any of my games, because I didn't need it yet. But using a game engine, you are kind of forced to use them. So I like frameworks more. Check my Minecraft clone, for example. Every system had to be done from scratch for it to work, like the chunk rendering or the multiplayer aspect. Or take my 2D game. It is totally different. So when I eventually made my own game engine, I made it more like a framework. It opens an engine window for you, and it has stuff like output reloading and input playback, and it has tools to easily add the 3D editor. But other than that, you write your own systems, however you see fit in your game. So I recommend you start making a simple framework. That can be something as simple as just taking all the libraries that you like and putting them all in a project, using CMake for example, and then writing the main function for it, opening the window, getting the input and the delta time. For that, I strongly recommend you watch this video, and then you have a framework that you can simply clone and start making a game in. My framework is in the description if you need inspiration. Or if you want, you can even make your own libraries for 2D and 3D stuff, instead of using pre-existing libraries, and add those to your framework, and make all your libraries interact nicely with one another. This is basically what I did. Then, you can also try to make a game engine. See, things aren't very hard if you take things step by step. Essentially, you just want to be able to have some entities, place them on the screen, and be able to do some positions, and that's about it. It doesn't sound that hard if you say it like this, does it? But wait, I will give you two very important tips before you go. First, I see that many people, when they make a game engine, just blindly make it how other engines are. But look, in the case of entity component system, I didn't use that for my games, though it can definitely be useful for some types of games. But should it be there in every single game? I don't think so. But I see that people just get used to it and literally can make a game without it, and that can be good.
No, you should use an entity component system factory. Shut it. I'm just making snake.
These things are just tools, and you should use them if they are useful to you. They are not necessities. Another example is adding scripting to engines, and I'm very much against that. So scripting was added so that artists could write code, and also to speed up the development process. But let's think about it. It is your engine, so you clearly know how to code. You can of course add a scripting language just for fun and for learning new things. But if you actually plan to do that, to actually use it, here are the downsides. Adding a scripting language means you need to integrate it with all your systems, so that means a ton of code. And if you use Lua, that isn't even strongly typed. So now you're making your code way less robust, way harder to refactor, and way harder to maintain once it grows, and also slower. And people will say that you write your code faster using scripting languages. But hear me out. You like Python because you can manipulate your strings easily? What if, instead of adding an entire language to your engine, what if you implemented those useful features that are in Python and aren't in C++, so that you can also move fast in C++? And also, why not spend some time making some memory arenas and temporary allocators and a good asset system, so you don't have to worry about memory leaks problems? I don't think this will take more time than implementing bindings for all your engine features. So then, why not just write your entities in a different class for each entity? And you can even use polymorphism if you like, or whatever. The main takeaway is to just try your own things, and not over abstract things. The most important tip though is to make a game with your engine while making your engine. And the reasoning is very similar to the previous tip. You might think that you need an entity component system, or that you might need your entities to be made in a certain way, or to have some features. But bro, you are just guessing. Realistically, you don't have that much experience in making games. So what are the chances your guesses are correct? So make a game while you're making the engine, and you'll see that some systems need to be added in the engine, that some systems are useless, and that some systems need some changing around. Now again, I have videos about CMake and other advanced stuff, but if you have never even made your first C++ game yet, congrats for sticking till the end. I promise you that I'm here to help you with this channel. So subscribe for motivation and knowledge, and go watch this full guide, because I can get to your first C++ game today with it. See you there.
University, and I decided to continue the project this summer. I'm actually feeling a little bit kind today, which is, if you know me, it's a bit rare, so take it. And I came across this beautiful email in my inbox, Radar Contact by Bogdan. Hello, I've created a 2D air traffic controller game using SFML as a project for university, and I decided to continue the project this summer. Now, this piqued my interest because I like planes. In fact, there was a time long ago where I flew planes, and now I just sit here in this room and judge people's code. Since the game is now in an advanced stage, I would appreciate it if you could review the source code. Here's the link, Radar Contact. Okay, we'll take a look at that in a minute. Radar Contact is a game where you have to manage an airspace and control airplanes to arrive safely to their destination airports, avoiding collisions and thunderstorms. You can modify the airspeed, heading, and altitude of an aircraft. The air traffic and weather is fetched from real life. The position accuracy of weather and airplanes is about 85 to 90%. Cool. So I guess he downloads like actual real air traffic and weather information. That's pretty cool. Also, you can play on 10 different regions. Thanks. And here we have the GitHub code repository. I'll have this linked for you guys in the description below in case you want to check it out. All right. So if you know my code reviews, you know that my judgment begins here. I judge the README. In fact, there was once a code review where I didn't actually make it past the README. If you guys watched like the last episode and you were like, boy, this guy didn't make it past the build system. Well, believe it or not, there was an episode one day where I literally did not make it past the README. I'll try and find that and have it linked up there. So in other words, we're doing quite well if we make it past this README. So let's talk about it. Download. Click on the latest tag available in release tab. Okay, cool. So we actually have a release. Version 3, 12. Wait, is that 12 hours ago? 12 hours ago. Damn. Fixed Iceland crash when playing in offline mode. This is lovely. I love seeing active development. Like I like seeing projects being actively developed. In fact, a lot of these commits are from like 11 hours ago. This is pretty cool. How to play. So run the game and select a region, available regions. Got quite a few available regions here. Looks like there's a little live data and offline button that we can choose as well, which is cool. After that, control your airspace. Give instructions to airplanes, helicopters, and hot air balloons. That's cool, to arrive to their airports. A flying entity will disconnect from your frequency when it's inside the arrival airport coverage area. So this yellow circle. In order to disconnect, some conditions required. Altitude must be below 10,000 feet and airspeed below 250 knots. Okay, cool. Collisions. Be careful. Yep, we know that planes can collide. Data of flying entity. Blue text represents new flight data if any has been given. And we've got call sign squawk. We got arrival. I guess it's an airport. Airspeed, shore, heading, altitude. Okay, cool. And then this is just the new information that we can reroute to, I guess. Okay, interesting. Keybinds, we'll look into this in a minute once I get this thing running. If I get this thing running, we'll see. Some cool resources here. I like the fact that this integrates with like real life, I guess, that it's not just like some arbitrary game that makes up its own data. It's actually fetching data from like servers and it represents like what's really happening, I guess, at that given moment. I'm guessing once you retrieve the initial data of all of these planes that are like in the skies or photo of this. And same with this weather information as well. Like it's all just retrieved, I'm guessing, from like actual real world data for that location and the planes, I'm guessing, as well at that given time. And then from there, I guess you kind of take over that realistic depiction of the airspace and then try and get them to land or leave your airspace, I guess, depending on what the goal is for that particular aircraft. That's pretty cool. Like this is, out of all the stuff we've looked at, this seems quite interesting and quite cool. Let's hope that we can get it building. Now, speaking of real world data and inevitably security, let's talk about NordPass Business, the sponsor of this video. NordPass Business is an all-in-one solution to help you protect and manage. Now, some critique on this README page. It's nice. I like that it's even got like updates and like I guess new features and whatever kind of showing here, but it's got a little bit of the same problem that the last code review had, and that is the fact that it just feels more like a game landing page. It has no information on the code or how to build it. Actually, I take that back. It has a little bit of information about the code, doesn't it? Because it's got resources and SFML and some other like I guess references listed here. But aside from that, like no instructions on how to build it, which is like how to build this thing. And there's no like building, .md like kind of page or file or anything. Like it doesn't. I'm kind of left on my own here. We've got some sanitizers and background structure, pretty cool to see. There's a CMake file, so I'm assuming you just build it based off that. But always include some kind of building like page or just like a little section here that just says how do you build this project, what platforms does it support. Actually, it says Windows 1, 2, and macOS, but I guess that's to do with the release. So whilst yes, if you're just trying to play this, I guess you can just grab this release for either macOS, Ubuntu, or Windows. But if you're after building it, really important that you have some information on how that can be achieved. Okay, so here I have the checked out cloned repository. Of course, I'm interested in the code, as I'm sure you are as well. That's why we're not going to be downloading a release. So let's see if we can get this thing building. So I'm going to take you through the build process because I don't know what the process is. I can see a CMake file, so I'm assuming that I'm just going to make a build directory. I'm going to cmd over here into this build directory. I'm going to type in cmake.dot, which is going to go back to the directory with that CMake file. Hit enter, and hopefully this will work. 294 seconds. 5 minutes. What on earth? How did this take 5 minutes to generate project files? That's insane. I thought this was like 2-3 minutes. 5 minutes I've sat here for. I need to like hire someone to just vet these projects for me and like present me with code that's already been generated or like whatever the heck, because this was just ridiculous. Okay, I swear if this doesn't compile. So radar contact solution file finally after 5 minutes of C making. Let's have a look at this. And I swear, like if this does not just, with the amount of testing it seems to have done here, if this does not build, I am going to be furious. Okay, so here's radar contact. Let's set this as a startup project. Let's just build the solution. I'm guessing half of the complexity, if not more, of this game is going to be just the networking and just being able to get stuff like download that real time or like real world information for the weather and the traffic, because C++ of course does not include any networking still to this day, which is odd. Good work, committee. So anything that involves networking in C++ is going to add quite a juicy layer of complexity to the project. Okay, finally, build started, radar contact. This is the project we've been waiting for after building all of those dependencies. I'm so excited. It seems to be building like on a single core, which is fun. Why is it taking, like it's not building the files in parallel? I'd love to see that. Everything else seems to be built in parallel, but I'm guessing like maybe this wasn't enabled on this project. And this is taking a sweet minute. Okay, finally, it's done. That took forever, especially on the last project. So for those of you who are wondering what on earth I'm talking about, if you open up the project settings under C++ general, over here we have multiprocessor compilation. This should be set to yes. Okay, so if I now take this, let's do project only, and we rebuild, because if you just do rebuild, it'll rebuild every dependency, which is crazy because I'm going to go through all of that again. So we can just do project only, which not many people know about, rebuild only radar contact. And so if we look at this now, it should hopefully do the multiprocessor compilation. And you can see how it just did all of those at once, because I'm actually on like this computer's like an old Threadripper, I think 1950 or something. Is that right? I don't really want to be wrong. Yes, Threadripper 1950X, 16 cores. So my 16 cores of compilation, which is like, yep. Whereas before we were doing one file at a time, which was crazy. So make sure multiprocessor compilation is on. You'd have to enable that obviously through CMake in this case, because CMake is used. So please make sure that is on. Okay, are you guys ready? Like, do you think this will work? I'm about to hit F5. I'm lying. I'm not about to hit F5. I'm about to click this local Windows debugger button. We're about to launch this. Is it going to work? The code execution can't proceed because OpenAL32.dll was not found. Okay, so OpenAL, for those of you who don't know, is kind of like an audio driver. It's not really a driver. It's kind of like OpenGL, right? But it's for audio instead. It's like some kind of cross-platform, cross-vendor way of like accessing audio devices and all that stuff. It wasn't found. Now I'm assuming that it is part of the dependency. I'm pretty sure SFML uses OpenAL, so I'm pretty sure it has to be here. So my strategy right now to fix this, because apparently we're fixing stuff now, is I'm just going to open this up in this tool that I love using called Everything, because it's like a searching tool, but you can see how amazing it is. I just typed in that path, or I pasted in that path, and it shows me literally every single file, 8,600 objects within this directory instantly. Like if I type in .slan because I'm looking for a solution file, you can see how quickly it searches through that. So I highly recommend this tool. I'll leave it in the description below. I've used it a few times. Some people have asked about it. It's great. I use it all the time to search stuff on my computer. If you're using Windows Search or any kind of built-in searching utility, you're doing it wrong. Like use this. And I'm just going to type in OpenAL32.dll, and you can see we actually got two here. So we've got one inside what looks like to be inside x86 and one inside x64. We are building x64 over here. You can see it's actually within SFML's external libs inside the dependencies that I guess CMake has pulled probably from the internet. So it's there. It's present. It's just for some reason not copied in to the bin directory. I don't know why, but that's not my business. I'm not going to actually fix that in CMake. I'm just going to copy this DLL. We're going to put it into actually before I copy it, let's look at the output. So both in build, which is gone now, and debug, there is a path to the final binary that it's actually, well, for debug it's obviously running it. So this is what it has actually loaded. That's the path. So I'm just going to copy the actual path itself here. We're going to paste that in. Here it is, radarcontact.exe. I'm going to copy this OpenAL and I'm going to paste it in here. Okay, and that's going to fix that error presumably. Let's hit F5. See what that just terminates straight away. Wonderful. So I can't actually run this project. Let's have a go at assuming that perhaps the reason why this is broken is because it can't load the resources. We've got nothing in this directory. I'm assuming that this here is probably the like working directory, right? So the working directory at the moment is set to the project directory, which is in fact this directory. Based on this, there's no files relative to this, whereas I'm sure there must be some kind of resources. So what do we have here? We've got flags, we've got fonts, we've got all of this stuff, right? Which is actually in the root directory of the repository. So I'm gonna just take a stab at this and just say, what if we go back a directory? What if we change the working directory to that? Let's see if this works. We did it. Okay, so little summary. Two things are wrong with this, out of the box, for me at least. I'm running this on Windows with CMake, whatever the heck. The OpenAL DLL, which is seemingly the only required DLL, which I'm guessing means that it's probably like either the rest is referring to DLLs I just have installed in my system naturally, or probably more likely everything is compiled into this exe. So everything's a static library. You can see 6.5 meg, although that is debug. No, still pretty big, 2.6 meg, right? So, and that's without resources, clearly they're not being packaged in because they're external. So that's a decent amount. The only DLL is required is not present, not being copied into the bin directory, so that needs to be done. And then the other thing obviously is that the working directory somehow is setting correctly, or resources aren't being copied into the build directory, which is another thing that maybe should have happened, but didn't. So that needs to be fixed. All right, finally, let's play this. Choose a region. Or who do I like the most here? Let's go with Austria. Why not? So the first thing that I'm noticing that I don't like is there's no, like, I can't resize this, which is a bit unfortunate unfortunate because it's a bit small. Like this is small for me right now. Someone with a 4K display would be absolutely, like, I'm guessing this doesn't support scaling. that would be even worse. Resizing or at least being able to zoom in, well, actually probably both. For me, full screen I think would be cool as well. So I'm not sure why resizing isn't a thing. All right, okay. So I can hold left shift and I can tell him actually you're gonna go that way. Okay, so he's beginning a turn, so this must be heading over here in the middle. And then it's gonna be safe. I'm kind of disregarded where he's actually trying to get to though, which is fun. We got the altitude with this stuff, so I can make him descend. Wait, that's the altitude? I thought the altitude was this. SP is supposed to be left control. Okay, so control is altitude. Unless my key, control is definitely altitude, and then alt is. I wonder if this guy maybe he's on Mac, like he's on Mac OS, and maybe he thought command or alt was different or something. I don't know. It's kind of fun though. Like it's interesting. Let me just find one plane and I'm gonna look at the code. I promise. So let's focus on this guy. TAH513. I believe in you. Let's go. So this guy needs to go to LOWK. So he's kind of going to LCAT at the moment, which is here. So he can probably begin a descent. So let's get that SP down. Let's get that altitude down to like shortest descent right away to 10,000. Let's see if he disappears. We did it. We did it. We landed a plane. All right. To be honest, pretty cool game. Don't really have anything against it. A little bit like hard to play though, just because of like the usability, I guess, and like of it being so small and not being able to zoom in and out. The controls are a little bit weird as well. Takes a little bit of time to get used to. It'd be nice to see some on-screen UI at least, like both explaining what the controls are, so I don't have to look at the README, but then also being able to like maybe like when I click on a plane to select it, seeing its altitude and airspeed and all the stats in a separate window that I could then just type in the number 10,000 or something into, or just click buttons on screen to reduce the altitude. Just because like dealing with the keyboard all the time like that is a little bit, it just takes a little bit too long. It'd be nice to have that on-screen kind of feedback and UI as well. That's the only thing I would say. Other than that, yeah, this is kind of a cool project. I honestly kind of like it. So let's take a look at the code and hopefully it will be equally as good. Okay, so I found this main file here. We can probably just start from here. So we've got like this header directory, it seems, with all of our headers. So let me just see what that looks like on disk first. So yeah, this is kind of a common thing that some people do that I don't like doing, and that is splitting up header files and source files, or like implementation files. So we've got the .h files, you can see all in one directory, and then we've got all the implementation files and CPP files are in a completely different directory. That's something a lot of people like to do. I personally don't like to do it. I like to keep my header files and CPP files in one directory. So you'd have like window.cpp and window.h. It's just, in my experience, it's a little bit easier to deal with just because you're not having to keep track of two different directories. If you want to give someone this file or like give them a copy of it or something, it's like you got to go back to a different directory, track down the header file. But one reason to do this though is because you can have your implementation details as like a hidden kind of private, section of the code, and then you can have a public section, which is your headers, which obviously dictate, how to use that API. So in that sense, it's actually quite good. So in conclusion, this is just something that I noticed, like it's a bit of a different way of doing things because we haven't seen it that often. If anything, I would say it's a little bit more like a professional thing to do, if you can call it that, not because of the fundamental, it's just something you see less often, I would say, from like beginners or even intermediate programmers, because like the reason really to do this is usually when you are trying to create that separation, as I said, between private and public code. But the reason why that kind of stood out to me immediately is because this is in a directory called header, which is odd because I would have assumed that header directory should just be in the compiler include directories, and then this would just work. So it's a little bit weird that we have to kind of go into the header directory. I mean, where is this relative to main anyway? Right, okay, so main is actually not in the source directory. Yeah, because this // like, I'm not sure if that's like necessary for Unix maybe or something, but you don't, obviously it's not going back a directory, it's just the current directory, and then we're going /header, so that's a little bit interesting. But yeah, the main directory, the main file for some reason is just outside of source. So that's a bit weird. What I would probably do to really clean this up is make a directory called source. Maybe inside that, I'd make either a directory called header or public, and then also private maybe inside that source directory so that all of your sources there, including the main file, and that way the root of your repository doesn't literally contain, like there's another header file here for some reason, then we've got source, then we've got header. This all really should be inside like a subdirectory. Just keep this a little bit clean. That's what I would do. Okay, so we've got try cache immediately in the main, and I'm guessing this exists because we have a custom kind of exception here, custom runtime error called error resources manager. So that's actually what happened, I think, when we ran this and we got that error over here in the output, which was our only clue as to why the game was just closing immediately on being opened, and that was because, yeah, we had a resource manager error. I guess I couldn't load that texture because the working directory was set incorrectly. So that's what this is. It should have printed out what it was, but for some reason we never saw a console. We never had an actual terminal or console be allocated after we ran this, which is odd. I'm not sure like why that's. We can see why if that's been deliberately disabled or if the system type maybe is set to something like Windows, which would explain it. Where is it system? Oh, system is set to Windows. Okay, well yeah, that would explain it. So if we had this set to console, then let me see if I can emulate what we had before because I really want to see if this person had like some kind of error reporting or not. So if I go back to having the working directory set incorrectly, let's run this and see what happens. Failed to load image, resources, general textures, menu.png, unable to open file. So and then texture error, menu.png, missing or corrupted. This is weird, right? So the configuration here, the type of application you could say this is being built into is a Windows application with no console. However, there's clearly logging going on. So where is it going? Is cout running to a file? You can really find a log directory or like a log file. So it's just a little bit weird that we have this situation here where clearly there's useful information that's just being sent into the void. Like why is this? This is potentially something that's only relevant to Windows. Maybe on Mac OS or Ubuntu, which this also supports, it's different. There's always a console because obviously there's literally Windows, the subsystem. I'm not sure, but either way, usually you would have this as like your distribution build because you don't typically like start up the game with an actual console. But like in Hazel, for example, we have three main configuration types: debug, release, and dist. And the dist configuration is the one we distribute, which that's like our final published game, I guess, or project, and that has subsystems set to Windows like this. But then we have console for debug and release because they're both used for development purposes, and we obviously want to see kind of logging and error messages like that. I mean, Hazel also has a log file, several log files actually that this would have ended up in, but yeah, just potentially a minor thing, but just really stands out to me as being weird. Okay, so the first thing we do, I'm not loving these instances. I'm also not loving that this doesn't have any kind of encapsulation of an application, right? So I like to stem these things from application. I don't really like initializing core systems just here, like inside main. I just think that main really should strictly be like an entry point. It's fine to define maybe, again, obviously this is all my opinion, but like I think it's fine to define certain configuration settings that are very relevant, like they're very important to the very core of the application. Potentially you could do that in main, but it really should just kick off the application. And the application itself should do things like instantiate maybe and load resources and like set up the state machine and whatever. So I don't know. I would personally move this out of the main like file, the main.cpp file, especially because like I would also argue that you probably should be using WinMain. So the WinMain would kind of be it's probably some weird Windows specific type or whatever, but like you would be using a different entry point most likely for Windows. In fact, it's a bit weird that it didn't require it. That's interesting, isn't it? Windows didn't ask for WinMain. Interesting, because I would have thought that it would have. So I'm not sure even why that worked, to be honest. I feel like usually if you use the Windows subsystem, it asks for WinMain, not just regular main. But anyway, that's another reason why, like, because you might have different entry points for different platforms, different build configurations potentially, it makes sense to kind of, because this is obviously common for any entry point, it makes sense to kind of put this into a more central location that's not specifically main, which again to me is supposed to be like the entry point. Okay, so let's see what this does. So we've got some singletons here. Again, I don't love it. I think there's very, very, very little reason to ever use singletons in C++. There are some valid reasons, but I just don't know why Resource Manager is a singleton that is kind of also lazy loading, meaning the first time we ask for an instance, it's going to run through and create this kind of static persistent instance of the Resource Manager, kind of on the stack here, but it's in like some kind of static memory, and then from then on it's going to return it all the time. So this is just kind of a nicer way to create a singleton potentially than like if you just had this as a static up here or inside the class or whatever, like you would have to like in Java or C#, for example. But this is C++. In C++, you don't need to do this. Like what you can do is just grab this Resource Manager instance, put it up here, call it global like this, for example, and you're kind of done. So you don't need this. Is what I'm basically saying. So you get rid of this. This is obviously going to cause a bunch of compilation errors, I'm sure. And then back in main, instead of doing this, you can just do this .load, right? And obviously you need access to this. You need to know what this is somehow. So you would probably have this in a header file, or you could just write something like extern this and then load it with a lowercase l. But that's it, right? So that would be a little bit more C++y. I think having this instance kind of indirection for really no reason is more of like a Java and C# thing potentially compared to C++. But I'm going to undo all of this so that we can still kind of play around with this. Let's look at load and what it does. We've got all these textures being loaded, menu.png loading script. Okay, so yeah, I don't like the fact that immediately there are lots of resources going on, I guess, inside the resource manager or the resources manager. And aside from all of this being, kind of just hard coded in terms of all the paths and everything, the directory as well is just being added like this. So I've got a few things to say about that. I don't know. I think like for a small game like this, it's probably not the worst. I just personally don't like. I would never do this because I don't want to deal with textures using strings. Like I don't want my primary way to identify a texture to be its string. To me, like a resource manager or an asset system would be, it's just a system. There's no data in there. There's no commands or instructions in there that are actually relevant to your specific usage or like your specific application. So what I'm talking about is that within the resource manager itself, we have a whole list of commands to load assets and resources specifically for this game, right? Menu.png is obviously something that is for this game. It really begs the question of like, why is this not external data? Why is specific data to this game buried inside?
Damn. Damn, this kind of sucks. Okay, we actually have to work. Oh, fuck.
The resource manager, whereas it should probably be external. And I think that it would probably work a lot better if it was like that. And the way that I think it would work, and the way I would make it work, is at like a light level. So what I mean here is that I don't want to over-engineer this because this is a relatively small game. It's not like a full game engine where we might have to do something a bit more robust than that or a little bit more scalable than that. But this, I think it's fine. At the very least, I would make like the menu itself give the command of what to load. So menu.png applies to the menu. Menu is the only thing, as far as I'm aware, that actually requires it. I can probably just search for menu.png and see that it's only in two places: the place where it's loaded and the place where it's used. So I would basically consolidate that in a way. I'd be like, okay, this is the thing that is requesting menu.png, and then I would simply get the resource manager to see that incoming menu.png request, in which case I probably also use the full path in this case. And then internally, the resource manager could just be like, okay, I already have this menu.png, so I'm going to serve you that asset and that's it. You can just use it. Or I don't have that loaded at the moment. Let me just load it first. And then again, I'll serve you that asset so that you can use it. Instead, we have like a central place where all of the assets are loaded. And then we refer to them, I guess, all throughout the code base by their path, but minus the directories. I think it might be like a good exercise to write like a little resource manager or an asset system. Just a really basic one, not like the one we have in Hazel, for example, but like a fairly basic one that can almost be used like this, but just is a little bit more external, I guess, with its data and perhaps more applicable to a wider range of applications than just like this system over here. That's another thing that I would say. Like, I feel like this is very, very specific to this game. game. I don't think that's necessarily bad, but for something like a resource manager, I'd probably make it a little bit more generic. I think looking through this resource manager, it's very, like, you can see pretty quickly, this is not just a generic resource manager. It's specifically built for this game. I mean, there's region, radius, zoom level. No idea why this stuff, to be honest, is part of the resource manager, but there's also other stuff like, you know, loading like some kind of long lat, like coordinates or something. There's like a list of airports that get loaded, which I'm guessing can probably come, well, okay, yeah, so there's a directory and it loads those specific, like, list of airports that we need to display. So that all falls under this load region function, which will load all the data associated with that region. We've got like weather tiles and everything being loaded. Like, this is very specifically for this game. And I think that's fine because, again, it's a small game. You don't really need to write everything within your code base to be generic and applicable to anything, because we're not trying to make some kind of generic game engine here. But specifically with this, as I was saying, it kind of just simplifies the code a little bit more, because you only ever refer to that resource where you need it, and then the resource manager behind the scenes will take care of it, and it doesn't care because it sees the identifier string, like, that identifies that resource, and that's it. It doesn't have to know anything else about it. It doesn't need to explicitly be told that, oh yeah, by the way, I want you to load this, because that will come later. The one advantage I can see here potentially is that you do all of your loading up front, rather than, like, you know, in my system, what would happen is when you open the menu, that's when it loads the texture. And then I guess what would happen later is when a plane landing, or at least when that, you know, class that has to play the plane landing sound effect, when that maybe gets initialized, maybe this constructor would load that. That could potentially cause like a stutter or something during gameplay, because it's only getting loaded when it's needed, if you know what I mean. If that's the first time that it gets loaded, whereas this does all the loading up front. But if you have to rename this file or like change and move to a directory, I don't know what happens, but if something like that happens, then obviously you now have to go everywhere and change it, because it's kind of repeated in multiple locations. And with this region, for example, I think I would also maybe move this into like a region file that deals with regions, right? Because there seems to be quite a bit of functionality around them. Like, there's this region box. I think we had region zoom levels. Like, what does that have to do with the resource manager? I think the resource manager should be kept a little bit more like a resource manager that is just your asset system, basically, that serves you assets that you asked for. And then all these other gameplay systems probably shouldn't be here. Now, I can also see quickly here with paths that when you combine paths, you're just doing this as a string. Let me just see what version of C++ we're even in here. So we're actually on the latest. We're actually on preview. So we're like C++ 23 here. So yes, in that case, make sure that instead of this, you use the file system API and you use the path inside there, because that kind of lets you do something similar like this. It's just that you don't have to worry about like slashes, for example. You can just replace them with this, which is like the same as a slash, but you're putting it over here. Actually, I think in this case, you might have to surround this with a path so that the overloaded operators work. Or I don't know, there might be other ways to do it. You could just set this initially and then add that on later. But the point is, I would use this instead, because that will create a path that is first of all valid for your operating system, just in case you want to use backslashes or forward slashes, it'll normalize all of that. And then also it's just harder to make mistakes because you don't have to worry about slashes and if there's a trailing or leading slash or not. Because if M selected region had like a slash, that would create a double slash, that wouldn't really work. So path is just a more kind of standard thing to use. And you can see that ifstream, for example, will obviously take in a path. I don't know why it's presenting it like this, but it's obviously got a constructor that will take in path as well. So it's not like you have to convert that back into a string for the actual C++ file API. That obviously works with these file system paths. So I would really recommend to everyone to use this file system path API instead of strings, like for all of your paths. Okay, I want to take over the state machine and then we'll probably call it a day. There might be a part 2 to this code review because there's quite a lot. I'm interested in the networking stuff that we're not going to be able to get to today either. There's like the weather stuff. This stuff seems really cool. So I think we will continue it. Let me know in the comments if you want to see a part 2 to this specific code base. But let's take a look at the state machine, like class and whatever, because I keep talking about state machines. I think I mentioned them a few times in my code review series because they're really good. They're a really nice way to kind of structure your application, because something like a game typically has multiple states. You might have like a main menu state like this game has, and you pick like the flag or the country or the region you want to fly in or control, whatever. And then it progresses, I guess, to the next state, which is the actual game. You might have like a game over state. There's lots of different states. And instead of just having like, you know, your main like game loop filled with if statements or switch statements that deals with it, having like a properly organized state machine is a pretty good idea. And I've actually said before that I wanted to make a video showing how you can convert like this mess of like branches and everything into a state machine, because that can really clean up. Still haven't done that. Sorry. Let me know if you want to see that in the comment section below. But let's take a look at this state machine. Or I don't know if I noticed this before, but there are these header guards, man. What is this, the 90s? Use Pragma once instead. I think, is that still not technically official? I don't know. Every single compiler supports it. Use Pragma once, much cleaner. You don't need these like weird header guards. Okay, so we've got state machine. We've deleted both the copy.
Bro, I don't know what half this code does.
Constructor and the I guess copy assignment operator or whatever it's called, and we just have a singleton, right? And then we've got a private constructor. Yes, so this is like a textbook singleton, which again you don't need to have a singleton in C++. It adds complexity, as you can see, for no real good reason. I'm guessing instance is the thing that adds complexity, as you can see, for no real good reason. I'm guessing instance is the thing that, again, like the resource manager and whatever, will actually, oh right, because I think this is, yeah, the state machine's the other thing we saw here. So loads the resources initially, so we got them all in memory now. What, does this initialize SFML? What initializes SFML? I don't even know, actually, how that gets initialized. Does SFML need to get initialized? I'm not sure. I haven't really used SFML probably before. But either way, instance run. Okay, so we've got apparently... I'm not sure. I haven't really used SFML probably before. But either way, instance... Let's run. Okay, so we got apparently. Apparently, we've got states already. In fact,
Wait, isn't this redundant? I'm pretty sure this is redundant, right? Oh, pop doesn't return anything. Okay. So I guess top back or pop back. Do we have a pop back here? That's funny. The search links to Google with sites. That's funny. Okay. That's smart actually. This is a shared pointer. Uh, what does that mean? I guess if it's out of state, it's closing. Okay. So it while okay, so this machine has a stack with states and continuously. Uh, continuously adds state to the stack. This is placed on the back, right? To the top of the stack, yeah. And then it works through that. Is that good implementation? In my opinion, no. Right? So this would mean that the current state is the last state it told the state machine to go to. Which doesn't seem good. Isn't it better to go to the first state? I don't know. I don't think this makes for good state machines.
The constructor creates a window state called menu. See, I don't like this. There's so much coupling in this code. There's so many systems. There's so many.
Let's look at my code. Okay. Can we go to this, please? Okay, so we basically have this might be wrong, by the way. I don't know what this actually does to be completely honest. This is the object. The current state is a reference to that state. So then we might have to go like this. Maybe. I'm not sure. But yeah, we basically have not implemented a way to do this yet. But it will basically be it's a good way of doing it. Default member initialization for current state. This is the null pointer. We can go like this, I think it's better. Is a pointer didn't mean yes. Then should also be a pointer, right? Handle events on. Okay, we don't need this yet. What does that mean? Can we go like this? I guess. Okay, that's up to a bit. Okay. Do not declare C silent. Okay. How do we do this again? std array of type transition with size 1, I think. Transitions. Something like this. Transitions. Okay. Ooh. Let's. Also, why doesn't this give me a warning? uh. I would like that. Okay, don't worry about it. Should probably not use it. Okay. So, our state machine will basically I guess we're gonna switch state on the state entry actually. I guess we can go with this. Does not equal this. Assert. Then we should go like. Where are we? Switch state. Wait, is this like a self switch state? Okay, we should have like some like current events, event tracker get events or something. I don't know type. Oh, what's it? But then like this is like I don't know. This will be like event type, I guess. Oh, we need to give reference to each of the states here. Uh, no, what's like a general size of this? Don't worry about it. Then we get, I guess, like, this is a dog shit way of doing it. Fuck me. Fuck. No, I don't care.
Classes that could be used somewhat generically, but
Like, why? Someone. I don't even know if this works, you know? We need like a general way to set the current state. Um okay. You know what? You know what? That's a good way of doing it, maybe. So instead of doing this, we give ownership of the events. Uh that has to be a good way of doing it, right? Okay, to do, I guess. To do. State entry should get ownership over event tracker, and while it runs, it can such that while it runs, it will update the current events. That might work. Robbery, separation, probably safe. Uh, almost misclicked this one. Okay, I think this could work well. So this switch state should be Jesus Christ, dude. Something like this, current events. Nope. Handle event. No. This is like while true, switch state. To now we're out of the entry function. So now we have ownership back of the event tracker. Maybe event tracker should have next state subject. Is this maybe a good way of doing it? No member get next state. I guess this is a private state type get no state type next state initialize to 0, I guess. This maybe. Eh? This is a bad way of doing it. Okay, event tracker. So now basically in entry time, no. While running. Okay, wait. Okay. Events? No. I guess events. Get next state. I guess maybe even like get possible next states. I guess auto get next state. Oh, you need to set the size here. Fuck. How to do this then? Oh my god, this is a mess. Oh, like architecture is so fucking difficult.
They're like the code is intruded. The specific code for this game and for this kind of application of the game, I guess, and of the system has actually been included within the system itself, which generally you want to avoid. And to be honest, like you can kind of see a little bit why. Like state machine instance run, what is that going to do? You have to look within that system to actually see what the system is doing specifically. You generally want to structure these things in software development as these kind of like black boxes, right? So you have these systems that you don't need to know the implementation of. This is actually even weirder because this game, this project actually made like a specific point of separating the headers, which is like the public API, with the source, which is like the private API. It's the implementation details. And yet we have so much vital stuff within those implementation details that dictates how this game actually works, right? So instead of that, like I would make this external. You'd have your state machine constructor be completely empty. And then instead of just doing run, because does this have like a push? Yeah, it does have a push state. So why not just make it like this instead? So you do your state machine, like, I don't even know if you need instance, because instance will create it. So let's just say that over here in instance, we had an empty constructor, right? And then this make shared menu state over here, we just push the state like this. And then we run it, right? Like this is how.
What are you doing on the stats? I gave up mentally. I checked out. I don't know. I don't want to do it. I'm not gonna lie. I'm procrastinating by doing fucking programming. I'll watch this and then try, you know?
This would be intended to be used, I would think. And the powerful thing here is that it completely
I can go full screen, I guess.
separates our data from the system, right? So we're not actually linking our system and its implementation details with specific.
As same as me when I try to do math. It's difficult.
data to like one way that we might want to run that system. So I am definitely seeing a lot of that, and I would
Also,
probably link.
I disagree with Shona here. Since, okay, say you have three, I guess 3 or 4 states. So a normal state machine, why can I not see anything here? Okay, you have state 1, state 2, state 3, state 4. So a normal state machine would maybe be like this, right? A simple state machine. And then you can say, yeah, I want to start at 1. And then it's obvious that I will go next 2, next 3, next 4, next 1 again, maybe. Hello. So like, I guess we'll go like this. So then we can have like, right? Wait. I hit that. I guess like state machine instance init or something. Let's call this photos if it's state machine init. Pretend like this is working, okay? Then you go FSM. What did it do? Like set state, push state, push states, result type. I guess we call it an int. I guess push state, state machine. Did you say? Make shared menu, right? And then he will basically go like this. Then we go, and for our case, we go, I guess, state 1, state 2, state 3, state 4, right? Then we will like walk down this tree. But when states become complicated, and you have some conditions, right? 2 can go from 2 to 4 or 3, or it can go back and wait. And it can also do some functionality over here. So it can do this AVBox functionality. You can run this, but also only if some condition happens. This becomes complicated, right? Because then when you have like, I guess, pushback state 1, and then it can, I guess maybe state 1 could be state machine. Let's see here. Make shared. State 1. Then you have to go state 1, add. Maybe add transition condition or something. And then like next state given condition or something. Then you can have. Maybe this is actually not a bad way of doing it when I think about it. Because then you can read the functionality of the whole machine here. Huh. And then this read surprisingly well. Damn. I might actually make it like this instead when I think about it. Because here you can easily see what states link to what other states. And then you can add, I guess you might even add objects here. So you can go like state 1 add action. Then I have some function here. It's like state 1 valve config, I guess set valves. Let's see what's shows up.
Linking our system and its implementation details with specific data to like one way that we might want to run that system. So I am definitely
Like, this is like, yes, of course. Damn. Since I'm basically, if you look at this, I'm basically defining how the state machine should run inside the state machine, right? You shouldn't do that. The state machine should be like a general object, and then you should define how it will be run inside here. So this shouldn't happen. You should have state machine. I guess we have like setup state machine here. So state machine, we have some add some transition, boom boom boom, save to state type R, burning given event. Then we basically have this thing, right? No. This should be transition, right? So like state safe on the FSM. Can you go like this? I don't know if you can go like this. FSM state list push back safe or something like this. Add valve config. Basically, state safe with some init function. Pushback safe. No, this wouldn't work. No. This shouldn't be a pushback. This should be some other way of represent it. So pushback implies that it works through the list of states, right? We don't want to do that. This should more be like some add state config or something. I don't know. And then maybe this, we can go like this. This will be init of safe. And then I can have each of these ones for each state, maybe. That could work. From SSV with some table, something like this, maybe. Damn, this could actually work well. New state machine design could possibly work well. State machine design, state objects are set classes work more as building blocks. But we can look like better state machine design, I guess. Damn, this was like a useful coding session.
Specific data to like one way that we might want to run that system. So I am definitely seeing a lot of that, and I would like really recommend, I guess, reducing that. So let's take a look at the run function over here. So while the states are not empty, we'll simply pop off the top state and then we'll run the top state. And then, okay, so if the current state is a menu state, then we will specifically check to see if the resource instance has been set to nothing, which means the game has been closed. Very interesting way to close a game, right? So what's happening over here is current state run. I'm guessing each state has to have some kind of loop, basically. So if we look at like the window run function, yeah, there's the while loop. What will happen is that the menu state will either pick a flag or obviously you just hit the close button or something. And if you hit the close button, it means that your selected region hasn't been set, it's empty. And so I guess when the menu state ceases to run, it's finished running. If we haven't set which region we want to play because we've like hit escape or closed or whatever, then it will actually break out of this and the application will terminate. So that's an interesting way to do that, I guess. But you can probably see from the way this is put together how it's actually working with a state machine. So it's just separated the game into these different windows. That's the other interesting thing, right? If we run this, you can see that this is one window, but then when I pick something, it opens another window. So this is another state. And this state, unfortunately, okay, this is still active and I guess I close it. What does that do? Okay, I guess that works. So I guess they're two different windows, even though this one stops running because it's obviously been popped off, so it's gone. Not really sure how that works, but yeah, this this game literally has different windows for different states, which is why the states are just shared pointers of windows of window classes like in a stack. So that would mean that the menu is a window, and then so I'm guessing if we pick something, right? So these are the region buttons, handle event, and then we click. So mouse button pressed, it'll probably push in a region, and then yeah, the data fetch stuff, which I'd love to get into next time, and then it pushes this game state into it as well. Okay, all right, and then the game and everything is also where the rest of the juice is. So I don't know, I'm not sure if this is really, I wouldn't really call this a state machine, because it's not really like it's just a stack of windows, really. It's a window stack. It's like a stack of windows that we want to get through and run like one at a time, which I don't think it's put together too poorly or anything. Again, I probably shouldn't be a singleton. And I also do find it a little bit weird that like there are specifically different windows for all of these different like layers, I guess, or different like states of the game. But sure. What do you guys think? Do you think that's weird? All right, I think we're gonna leave it here. What did you guys think of this code base in general? Did I miss anything? Obviously, we haven't looked through most the code. I think we'll get to that in a part 2. The game itself, as I said, I enjoyed. The code, like the biggest thing really that sticks out to me is just like that tight coupling of like having data within systems. Like, I don't know, on one hand, I think it's okay to do stuff like this sometimes in a small project like this, where obviously
Will with age. Well. Well. Willow. Will be a late night today. Stats later on. Do so. Can we look this ones? Tab 2.
time for another code review. What's up, guys? My name is Achona. Welcome back to the series where you guys send me your code and pro VS. That's not necessarily a good thing. But also, the engine won't work if you don't have the engine as well the user project in the C directory. How am I going to be nice about this? This is Renee. Sure. I actually don't know what that is. It looks like it's got quite a lot of features, as I usually do, but that's a fantastic start, strong start. Hello, I've been working on my game engine for about 2,000 hours now, and I really would appreciate it if a professional could review my code. This project is going into my portfolio, so roast me as much as you can. I was into it. I expect this is not just a small project. Okay, so let's kind of maybe read this. I'm bigger.
How do you even spend 2,000 hours on hobby? That's like a full hobby, or full day of free time spent on the hobby each week. No, each day for an entire year, I guess. Like 4 times 365 then, I guess. Yeah. 4 hours. This is like impressive.
Apologize profusely if they are. The engine calls one update and one start.
Um, I guess we can like split this up a bit. Mm. Maybe it's not smart to change. How it's built. Should we have like importance there? No. This doesn't need that. State. Uh. So we want state type from, state type to, event type condition, int important. I guess enum class importance maybe. Critical. If we just have a number system, right? We can have execute the state with the lowest priority first, or the highest priority first. Then we can have basically infinite, but that's less clear to read, and I don't think we need it. So if you have importance, critical importance, none, and then importance, standard, then we can do, where were we? Importance, priority. I guess something like this maybe. Importance dictates which state to go to if multiple states meet the condition. This is smart, I feel like. This is, like, I'm feeling smart now. FSM, no, FSM result. So now we go to transitions. This will be in models, I think. Okay, so we want to, each transition should have state. Ooh, that's bad. Since now we have defined states type multiple places. Guess that could work still. Event type, why doesn't that work? That's below. State event importance. Importance. I guess priorities. Then we go transitions. Push back. Why doesn't this work? Type def struct. Oh. Do they want like a T here? Um, what do we need? We kind of know what it's from. Do we got two? Two, no. State. Dot state. Given event. Condition. Priority. So now two. Parameter 2 is too short. To state, I guess, go to state, go to state, I guess, maybe. Okay. Then I guess we have get next state, maybe. Get next state. Run. I really like this though. Okay, so in the main CPP, we will end up having something like we will end up having something like FSM. If FSM can go next state, given events, do we not skip event tracker? No. If can I go next state? Okay, never mind. I guess, okay. No, maybe not. Maybe we should have the init here, and then we should have an FSM run function. In the run. Hello. In the run. Where's the missing?